Hello, Professor. I'm Vamsi Copesetty. I'll be talking about the Banyan network. The Banyan network is a combination of Batcher sorter and the Banyan network. The Banyan network, one of the most important point is that there's a single path from each input to each output port. The Banyan network has the following advantages. They are high degree of parallelism, self-routing, and modularity. Before we go in deep into the program, let us take a simple example. And in order to understand Banyan network better, so in the example given below, the target is that first we have to, the packet must be traveled from the source port, which is 1, to the destination port, which is number 5. So that is our main target. So for this, what we have to do is that first we have to convert the destination port, that is number 5, to binary, which is 101. For this 101, what we have to do is that once we take the 101, there are 3 bits. So 101. So we start off with the first bit, which is 1. We start with the lower half, which is the bottom portion. That is the lowest, nothing but the bottom one, bottom portion. And it gets started and gets traveled midway, and then it goes to the upper portion, which is the reason being the second bit is 0. And then from the second bit 0, it goes again and reaches finally reaches the destination. So as we have understood what is as we have got an idea what is a Banyan network, let us straight jump into the program. Now this is the program and this is the execution and this is the output. So from the output, it's clear that there's a random list of inputs, and the first step is that it gets sorted in binary, and then the Banyan network is being displayed. Now, let us go step by step. How does it work? Let us go step by step. The first step is being the 3 steps: random generator, batcher sorter, and the Banyan network. First is the random generator. How do we generate a random input? In order to do that, we use a thing called new array list. So using that, we initialize 3 things: minimum, maximum, and the range. So for a better understanding, let me show you the code. So yeah, here we use, as you have mentioned, this is a random input generation. So this is the highlighted portion is a random input generation. And as I have mentioned, we have initialized 3 things: minimum, maximum, and range. And we use a loop called while loop. And along with the while loop, what we do is that we implement a function named math.random, and for random input generation. And here it is, the random input list is being printed out, and then using the for loop, the input is being created. And then we move on to the 2 types of implementation, which is batcher implementation and the Banyan implementation. The batcher implementation is nothing but, for the batcher implementation, what we use is that we use a very important function named batcher sorter. And yeah, for the batcher sorter, first what we do is first we print out the batcher network, and then the batcher network and the sorted input. And then by using the for loop, we create a sorted input, which is basically, yeah. And then we move on to the Banyan implementation. For the Banyan implementation, again, we use a for loop, and we created a sorted input, and that's how it is being shown. And then here it is, the most crucial part. Here it is nothing but the input binary string to path is basically a conversion from it gets converted basically. So the thing is, first we use a function called Banyan network. In the Banyan network, we use 4 strings: string A, string B, string C, and string output, and 4 switches: switch A to B, switch B to C, switch C to output. Yeah, we use it, and we equate string A to input ports of input port, and then we equate string B to switch A to B dot get A by using chart at 0, and then the C gets switched to get of B, that is switch BC to input dot chart at 1, and then string output to get C input chart at 2, and then we print the output. And this is the main execution of the batches sorter. So here the batches sorter, for the batches sorter, we collect the set of inputs and and then we append it, and that is a basic conversion from the integer to binary, and then we provide the output. And here is the initialization of switches, what we have already earlier used, we have used earlier. So this is a basic implementation of that. And then coming back here, here's a source code for 8x8, and the same for the coming to the 16x16, the same the 16x16, the working of 16x16 is similar to 8x8. The only reason is obviously the random input list goes on like it is a 16x16, so the inputs must be between 0 to 15. That is a basic difference. Other than that, more or less it will be the same. And here's the source code. Now, jumping to the conclusion, the program has been successfully tested, and the provided document desired results. The desired results are being provided for both 8x8 and 16x16. The simulation results that are being presented here and the document are very much useful for MIN, which is multi-stage interconnection network. It is regarding two things: network throughput and performance parameters, which is under loads and different loads and buffer sizes. The packets are uniformly distributed across all the destinations. Thus, the network is efficiently used. Thank you.